In section 2.1, we will be discussing if-then statements and converses. Now you see a statement written here at the top, and it says, if tomato is a fruit, then ketchup is a fruit smoothie. This would be an example of an if-then statement, because as you see, there's an if portion and a then portion. Another name we can give to these type of statements are called conditional statements, or just simply conditionals. Now, we're going to analyze the different parts of this statement, and the first part is what we call the hypothesis. That is the if portion. So in this example, if tomato is a fruit, that would be your hypothesis. The conclusion is the then portion. So it says, then ketchup is a fruit smoothie. That would be your conclusion. Now, instead of writing out the entire statement every time, we can simplify this by using letters to replace the statements. So here we see if P, then Q. So looking back to the previous example, we can replace tomato is a fruit with the letter P. So that way we don't have to write out that whole statement every time. And then ketchup is a fruit smoothie. We can replace that with the letter Q. So that way we don't have to write that out every time as well. We have another term here called the converse. The converse is simply when you switch the hypothesis and the conclusion. So instead of saying if P, then Q, you would say if Q, then P. So looking back at the previous example, instead of saying if tomato is a fruit, then ketchup is a fruit smoothie, the converse would be if ketchup is a fruit smoothie, then tomato is a fruit. Another term to know is the term counterexample. Counterexample is simply an example that counters or contradicts the original statement. It's something that disproves what you're trying to say. So, for example, if you have the statement, if Ed lives south of Canada, then he lives in Texas. What we want to do is we want to find something where the hypothesis is true and the conclusion would be false. So for example, we could say that Ed lives in Mississippi. Okay, well, the hypothesis still would be true. Ed would still live south of Canada, but the conclusion would be false. It does not mean that he will live in Texas, because he could live in Mississippi. Or he can live in basically any state in the United States. So a counterexample would be something like that, where the hypothesis would still be true, but the conclusion is false. When you're looking at if-then statements, there's different ways that you can say the same thing. So make sure you can identify the ways that you can write the same thing. So you see here on the left, it says, if P, then Q. Okay, that's a statement we've been using. Okay, but we can also write this as P implies Q, P only if Q, or we can write this as Q if P. These are all the same thing. And if you're looking at actual examples, just simply replace P with the statement and then Q with the other statement. So P and Q are just representing any statement you can use. Here's an example on the right. We see here if x squared equals 25, then x is less than 10. We're going to let P be the hypothesis, so x squared equals 25 would be your P statement, and then x is less than 10 would be your Q statement. This would be your conclusion. So if we look at the other alternative ways of writing this, we could say x squared equals 25 implies x is less than 10. We can say x squared equals 25 only if x is less than 10. Or we can write this as x is less than 10 if x squared equals 25. And then lastly, we have what's called a biconditional statement. The word bi means to, and so this is a statement that can be written with two parts being true. We write this as P if and only if Q. What this means is if P, then Q, and if Q, then P. So this sounds kind of ambiguous, kind of vague. So here's an example on page 35 in your textbook, number 8. And we see here that there are two statements written. The first statement is if the measure of angle AOC equals 180, then angle AOC is a straight angle. The second statement is if angle AOC is a straight angle, then measure of angle AOC equals 180. Notice we have the statement and the converse. And for a biconditional, both must be true. The way we would write this as a biconditional would be measure of angle AOC equals 180 if and only if angle AOC is a straight angle.